much. Good afternoon to all. May I request Dr. Suresh, the organizing secretary, to welcome the gathering.
Thank you, sir. Dr. Jesus Rajkumar, sir. Very good afternoon to one and all. I would like to welcome our Director of Sports, Dr. Regression, sir, for today evening sessions. And I am extremely happy to welcome our Honorable Dr. S. Ponnusamy, sir, Registrar of SRMIST, for this national level webinar. On behalf of Department Director of Sports and my own behalf of, I welcome our today resource person, Dr. A. Duraisamy, sir, Dean, College of Science and Humanities, SRMIST, for this day-to-day evening sessions. And I would like to welcome all the participation from around in India for these day-2 evening sessions. Welcome and one and all. Thank you.
Thank you, Dr. Suresh. May I request our Honorable Registrar to give the inaugural address. Sir, please.
A very good afternoon to all of you. Dr. Mohan, Director Sports, Professor Duraisamy, Dean, SRM College of Science and Humanities, my dear colleagues from the SRM Institute of Science and Technology and the Directorate of Sports. Once again, a warm noon for everyone. See, SRM Institute of Science and Technology has been in the field of higher education for the past 5 decades. And we have been ranked in the university category in 19th position as per the NIR of 2022 rankings. Also, SRM Institute of Science and Technology is placed in fourth rank in ARIA ranking and rating procedure. And our Honorable Chancellor, Pro-Chancellors have been consistently supporting us in providing good infrastructure facilities for research. As of now, we have been spending on an average of 7 to 8% for the research in the total annual budget. See, in the university, if you see the total equipment, cost of equipments which are available, it comes around 150 crores. We are also having a separate research building which is named as the Sir C.V. Raman block. Majority of the research equipments are being housed in that block, and we are having a full-time research scholars of roughly around 2,500. And the total research scholars in the university are roughly 2,900 and all, out of which almost 70% are the full-time research scholars in various departments. So we have been performing well in academics as well as in the research. And this workshop, the 2-day virtual national level webinar, how to write scientific research articles and to publish in Scopus and WOS indexed journal, would be useful to all the research scholars. And because nowadays writing, publishing is a great task. And see, especially this Elsevier journals, they do not accept the research articles as it is. Sometimes, they just go through the language and return the paper back, stating that your language is very poor, improve the language. And there are several this English language supporting services for that, and we need to pay some amount for it. Now, I hope after attending this workshop or the webinar, the research scholars would be able to improve their writing skills, and they know the technical skills, but sometimes poor presentation lead to rejection of the research articles from the journals. And in this aspect, I appreciate the efforts taken by the Directorate of Physical Education, and Directorate of Sports, Department of Physical Education and Sports Sciences, for coming out with such idea, and the deliberations and the discussions that are going to happen in the afternoon session, as well as for the past 2 days, would be useful to all the research scholars. On behalf of the management, I appreciate all the participants, the guest speakers, and all the faculty members and other technical team involved in this webinar. So thank you for this opportunity. I hope all of you will get a positive note and utilize this lecture or the webinar, and you will get to good articles and publications in reputed journals. So thank you very much. Thank you very much for this opportunity.
Thank you, sir. Thank you, sir.
Thank you so much, sir. Thank you.
Thank you so much, sir. Dear participants, I feel immense happiness to introduce our research person. Dr. A. Durasamy, Professor and Dean, College of Science and Humanities, has been teaching economics and economics for the past 30 years, from 1990 to 2020. I retired as head of the Department of Economics and Dean of Humanities, Madras Christian College, Chennai. He has adjudged as the best teacher of economics in Tamil Nadu for 2020 by Malcolm Elizabeth Associate Trust, Chennai. Received Senior Economics Award from the Association of Economics of Tamil Nadu, the 40th Annual Conference. Dr. Durasamy has a PhD in Economics from the Madurai Kamaraj University, Madurai. He did BSc Mathematics and holds a Master's degree in Mathematical Economics and MPhil in Economics. He also has an MBA degree. 40 MPhil scholars and 12 PhD scholars have been already awarded degree under his research guidance, and at present guiding 4 PhD scholars. Conducted around 50 workshops on data analysis using statistical packages like SPSS and eViews, through which at least 1,500 research scholars of humanities have been benefited in strengthening the research analysis. Sir, over to you, sir. Dean, sir.
Thank you, Dr. Louis. First of all, I thank the Department of Physical Education and Sports Science and Department of Yoga for giving me an opportunity to share about how SPSS can be utilized for analyzing the data, especially in social science research. And I congratulate all the participants, and I also thank our beloved registrar sir for giving his remarks on this 2 days virtual national level webinar on how to write scientific research articles and to publish in Scopus and WOS index journals. As administrator, sir knows very well about how difficult to make the faculty members and research scholars to write the quality articles. He is always very much keen on quality rather than quantity. I have, whenever I speak to him, he is insisting that, you must ask your research scholars and the faculty members to produce high impact factor journals. So that such a kind of motivation we get always from our registrar. Thank you very much, sir, for that motivation. And definitely, I think I'll take the next 1.5 hours to make these participants believe in themselves that, yes, they can do their data analysis in a better way by using the packages like SPSS or eViews. So in analyzing the quantitative data as well as the qualitative data. My dear participants, so when you think about writing an article, first you have to find out, you have to identify the right kind of an issue, and then only you have to move forward with that research. Whichever subject it is, either it is from the physical education or it is economics, commerce, sociology, social work, any discipline, the first and foremost important task of any researcher is to identify the right problem. That is the first point. And after that, definitely, I think you are not going to be the first person to do research on that particular topic. You must have that thing in your mind. You are not the pioneer of doing any research, because the research starts even 500 years back, 600 years back. So in the thirst of the knowledge, we are always searching the new things. But you should also keep it in your mind, there are somebody who had already done their research, who had already dealt the issues which you have taken in that one. So once if you identify an issue, whatever it may be, say for example, now COVID-19 was an issue, and COVID-19 had an impact on every aspect of it, either in our day-to-day life, or our income, or our expenditure pattern, or our relationship, or our travel. So anything, we could see that there is a kind of a problem in it. So you can think as a research scholar, yes, I want to do a research. Yes, I want to do a research on it. Fine, right. So the next step is you have to go back and see who are all done research related to that particular topic. Okay. And that will be nothing based on your review of literatures. Once if you had a thorough knowledge about what they have already done it, and you can identify the research gap, or you can even find out the research issues related to that one. For example, one of my research scholar is doing on the online marketing. Okay, her intention is to study how this online marketing create an impact on the economy, either in the form of consumer analysis or the seller's perspective, or from the macroeconomic point of view. So she has to identify the research issues. She had to list out the research issues first of all. And in the last 3 sessions, yesterday 2 session and today the morning session also, definitely you might have had a thorough deliberation about how important those kind of review of literature. Okay, fine. Let us assume that you have done a review of literature. So while you're going for a review of literature, definitely you could have got an idea about what are the theories associated with your research work. If I do something on poverty, definitely there are certain theories done by the earlier researchers, well-known researchers, that this is the theory. For example, the famous, let us take Malthusian theory of population, or there are various management-related theories, employment theories, price theories, and psychological theories. So every subject which we do it, even if it is a physical education, definitely the development would have been expressed in the form of theories. Okay, fine. So you must have a very good idea about the problem which I have taken for my research is associated with what theory, or which theories are given by which famous educationalist. So that is the next step of that. Okay, fine. So now you got the theories also. Right. Now the question is, the big question for any research is, please listen, the big question for any research is the theory which has been existing for a longer time is relevant now? That is the first question. Or the situation which I am facing now, will it be suitable for the theory suggested by the earlier educationalist? So here comes the question of relevance of the existing theory. Whichever subject you can take, relevance of the existing theory. Say, for example, in early days, like watching a 5-day cricket is an order of the day. But later when time comes, what happened? Then 50-over matches have been. I still remember even when I was a postgraduate student, I even apply leave and then watch right from the first ball to the last ball of that 100th over. But are we having such a kind of an intensity to watch a match now? Definitely not. Over a period of time, the kind of, the expectation from those 8 hours has come down. Now we are moving into 20-over match. So we are willing to be associated with only 50 to 40 overs or 3 hours, 3.5 hours. And who knows, after 10 years, maybe there may be 10 overs tournament also can be. So my point is, over the period of time, the relevance of what we believe that yes, it is questionable, right? So now, as a researcher, you have identified the problem, you have gone through the earlier review of literatures, you identified the research issues, and then you have related with the existing theories, and you are in the stage of questioning the relevance of the existing theory. The answer may be, yes, it is relevant for this country or this region or this particular time period. Or the answer can be, no, this is not relevant for the current era. This is not relevant for this particular region. It may be suitable for India. It may not be suitable for America. So something like that. So question is that, is it relevant or not? So now if you want to answer the question, yes, it is relevant or no, it is relevant, then you need some tool. You need some technique, because you cannot simply say that your belief may be different from others. So you cannot trust upon your view on it. Say, for example, is this 20-over match is good or not? Then you may have an opinion that, I want this one. So I want the shorter form of the game. I still even remember when I was playing volleyball in college days, there was 14 points only. So even the side over, we don't have a points. We have to win. We have to we have to play even 10 points, 20 points. After that only there's a possibility of earning 1 point into that one. It was the early days, but now it is not like that. They too realized the need for advertisement, income, time, everything. I still remember even a game of 14 points will go for 2 hours and all. But now it is not like that. 25 service this side, 25 that service that side, match will be over. So because of the timing of TV, because of the income and all those stuff in it. So over a period of time, the need will change, the ideology of those things. So my point is, any researcher has to cross this stage of questioning the relevance of existing theory, and your entire research is based on finding the answer for that question. How do I answer that question? Definitely, I think you have to answer that question only with the help of analysis. Analysis need not be based on data. It can be even in the form of, see, I want to see the playing behavior of the youngsters. So what should I do? Either I can go and meet some of the youngsters in the age group of say 5 to 15 or 15 to 30 and ask them some questions. How much time do you spend for game and all those things. Otherwise, what I will do, I will go and live with them. If I want to understand the tribal behavior, I have to live with them and then observe and write. And then I can say that I lived with them for 1 month or I lived with them for 6 months and I have observed this is what happening. So you have to believe in. You can write that as there is no data analysis. It is simply collection of information by observing what you have done it and you are writing the summary of that one. This is also one way of analyzing this one. But most of the time, this may not be acceptable because another researcher go to the same tribal village and he is also staying there, but his view will be different from others. So my theory here is that any analysis must be based on scientific method. What do you mean by scientific method? A scientific method needs a hypothesis. A scientific method needs a hypothesis. Hypothesis is nothing but a tentative statement. For example, girls are better in sports than boys. I may reject it or I may accept it. Okay. Or I mean this particular training has given a better performance for the cricketers, or there is no connectivity between the training and performance. So I need some hypothesis. Hypothesis is nothing but a statement of chance of rejection as well as acceptance. So you understand the theory, you identify the problem, and finally you have found out which is the research issue, and you have converted that into one single line of there is no relationship between X and Y. But at the end of the data analysis, I'm going to say, yes, there is a relationship, or no, there is no relationship. Hope you understand. So to reject or accept that one, we need some kind of a help. So where we get help, we can always get help from statistics, because statistics is a subject which deals the population with the help of a sample. Like, so what is the behavior of the rural people towards the OTT? I can't get each and everybody's opinion, those who are living in the rural area. But what I do, I just select some of the villages and I collect information from 600 or 700 or 30 or 40, whatever it is. So I take a sample and I get information. The information is being converted into numbers. And then with that number, I do some analysis. For that, years, hundreds of years, the statisticians repeatedly do some analysis based on the same set of data or different set of data. And they have come to a conclusion that, yes, if you analyze like this, you can be able to find out the relationship between two things. You can analyze one particular variable, or you can deal with the qualitative data. They have done everything. They have given you the juice of what they have found out. So only thing is, now you have to understand and then apply the tool for your data and come to a conclusion of rejecting or accepting the null hypothesis, by which you can say, yes, I agree, there is a relevance of this theory, or no, there is no relevance of the theory. This is what, as far as my knowledge is concerned, to start with a research and do continue with that one, whichever be the subject. So hope you understand. And suppose at this particular point of time, if any one of you have a doubt, please don't hesitate. Please, you can, open your mic and then you can ask them. Please. Anybody, faculty or whoever it is. Okay, right. Suppose if you don't have any doubt, doesn't matter, right? So now the point is, yes, I have, I have come to the stage of formalizing my hypothesis. And null hypothesis has, please.
Excuse me, sir.
Yeah.
Sir, how many types of hypotheses, sir?
Yeah, okay, good, right. See, there are only two hypotheses we have to concentrate on this data analysis. One is null hypothesis, the other one is alternative hypothesis. I wish you to ignore that alternative hypothesis for a moment. Okay, so always in your thesis, you write the null hypothesis. Okay, fine, which means null means nothing, zero. So we don't have any doubt about it. For example, training and performance of a football team. Training and performance of a football team. Okay, right. So you observe a training behavior of 30 days, observe the performance of 30 days. Now there are two variables are there. So in mathematics, we have this concept called variable. Variable is nothing but the certain things which vary from person to person. Suppose if I ask you, how much money do you have in your packet now or in your wallet now? If there are 100 students are here, I will get 100 values. So I write 1, 2, 3, 4, 100 values, and not all the 100 values are same. So that I can say it is variable, vary, right? Suppose if I ask you the question, how much you have paid for registration? I mean, I assume that there is no concession. So all of you participate, there are 50 participants, everybody will say 500 or 1000, whatever it is. So everybody giving you one number. So there is no change in that number. So it is a constant. If it is variable means every person, it may vary, or at least 2-3% may give you the same answer, doesn't matter. but the entire list, if I put it, it may vary. It is not single number. It vary. As long as it vary, you have a scope for analysis. You have a scope for analysis because most of your research depends on finding out the answer for why there is a variation. Why there is a variation of a particular team over a period of time. Why there is a variation in admission in SRM. Why there is a variation in the savings of a family. So if there are more variation, obviously you have a more choice of listening, understanding, analyzing that data so that you will get a clear picture about what is the pattern on which there is a variation happen, or why there is a variation. It could be because of some influence. So what is the variation in training influencing the variation in performance? But there may be a kind of a relationship, like if the training goes up and up, then the performance level will go up and up. So there is a possibility of positive relationship. Sometimes when the training goes up, the level of failure may go down. The error committed by our players will be less and less. So there is a negative relationship. So there could be a positive relationship or negative relationship. Only these two things. And there could be a possibility of only two variables. Say, for example, performance and the training. Only two variables could be. But other than this two variable, age is also a matter. Age is a matter. So a training given to a 15-year-old, a training given to a 30-year-old, though the training is same, the performance might be different because there is another variable which is nothing but age is matter. Another variable, gender is a matter. So it is not always we concentrate on one-on-one relationship like performance and training. So beyond that, performance, if you take it as a dependent variable, performance is the ultimate variable I want to analyze because I'm more keen on why there is a variation in my performance. So I want to see why there is a variation in the performance because I want to make it as constant so that I will successfully win in the matches. So my variation in the performance depends on my training variation, my age variation, my gender variation, and so many other things. So it is not a question of one-on-one relationship. It can be one-on-n relationship also there. Is it okay? Right. You asked the question about how many hypotheses are there. For this research, better concentrate only on null hypothesis. Alternative hypothesis, obviously there is, say, my null hypothesis here in this case, there is no relationship between age and performance. I assume that irrespective of the age, the performance is same. We all very well know about that age and the performance are related. But in some case, say for example, chess, if we take chess, definitely I think age is not that much matter like cricket or football. So it also depends on a particular game on which you are going for it. So now the age vary, right? Age vary and performance also vary, right? So here I just set a null hypothesis first of all that there is no, for a null hypothesis you have to always say there is no relationship, there is no significant relationship, there is no statistically significant relationship between the independent variable age and the dependent variable performance. All right. Okay. When I say no relationship, that is null hypothesis. What is the alternative hypothesis? Obviously, there is relationship. There is relationship. So if you take such a kind of relationship, then we call it as a two-tiled hypothesis. So two sides. I say there is no, there is. So this is one way of looking at it. Let us stick on to this one. But there is another type also. For example, I take a null hypothesis that there is no difference between the performance of girls and boys in the field. Okay, there is no difference. Always null hypothesis, there is no difference, there is no influence, there is no significant difference. It is what like this. So I say that there is no significant difference between boys and girls on the performance, right? That is null hypothesis. What is alternative hypothesis? There is a significant difference between male and female, between boys and girls. Then immediately you will ask the question, sir, are you saying only there is no difference, or you are going to say, no, are you going to say only there is difference, or are you going to specify boys are better than girls or girls are better than boys? So if you take there is difference, then it is two-tailed. If you want to specifically say boys are greater than girls, then it will be one-tailed test. Okay, let us not go into detail about that. It will take a lot of time to teach statistics into that one. But I just give you the two-tailed test in this one, right? So now, hope you understand that. Again, I repeat, your identification of the problem, review of literature, research issues, maybe converted that into research questions, your objectives, theories, very, very important. From the theories, you identify your hypothesis involving either two variables or more than two variables, or more than two variables. And then what we do, we just go for analyzing that null hypothesis. So if you want to reject or accept the null hypothesis, you need analytical ability. You need scientific method of analyzing that one. For that, you should have a little knowledge about statistics, mathematics. Okay, fine. Even if it is not mathematics, little bit of statistics is necessary for that one. But nowadays, you have a lot of packages like SPSS, eViews, StatTask, MATLAB. So many packages are available now. R is a best package. I think that Ramona Krishnan will incorporate that R program in every UG as well as program, so that I think they can excel. Because nowadays, sports analyst is a key job. It is a highly demandable job, highly paid job, sports analytics. Okay, I'll come back a little later. All right. So now we are going to the data analytics and how to collect data. What is your sample size? I think it would have been discussed. Fine, right? Is it okay? Shall I move into the data?
Yes, sir.
Okay, good. Right. Now I'll show you an SPSS data. Okay, this is my SPSS data. I just take it. It's again given in like. Yeah, fine. Okay. Right now, hope I think most of you may be familiar with SPSS, or do you need little time for me to spend on how to create a variable? Anybody? Okay, fine. So when you open SPSS, you will get a data view in the bottom left. You can see data view and variable view. Okay, so this is variable view. So I have taken an example from SPSS itself. So this is nothing to do with sports. I just taken a general one. But once you learn how to do it, then it can be easily applicable for any subject of your nature. Right? So now these are all, there are 43 variables are there. So the first one is you just concentrate on only name of the variable, label of the variable, and values of that one. If you have a notebook, please take a note of it. And if you're familiar with SPSS, forget about it. Okay, right. I just take 5 minutes for introduction. So name of the variable is very important. Label of the variable is important, and value of this variables are important. And you need not worry about what the other things are there. So once if you get familiar with SPSS, then I think you can easily understand what the other columns are. So name, there should not be any gap between one word and the other word. Say, for example, family income. So you can say simply FLY, dash is not accepted, underscore is accepted. Dash, if you write FLY dash INC, it won't accept it. It won't be accepted, but underscore is being accepted by SPSS. Okay, right. So gender, what is this? You can write here. And look at this value here. So you are everything converting into numbers. So here you have given male is equal to 1, female is equal to 2. But my simple advice to you all here, my dear participants, if you have only 2 categories, like employed, unemployed, male, female, married, unmarried, sports person, non-sports person. Okay, whatever it is, if you have only 2, then better give 0 for one category, 1 for other category. Right? Is it clear? So you may ask that, sir, which one I give 0? You may ask, which one I give 0? Which category in this male and female in sports not given much importance? Which category of this 2 in sports is not given much importance? Answer, please. Okay. Can they unmute and speak, or you have muted everybody?
So muted everybody.
Everybody can know. So if you want, you can unmute yourself and speak and then mute. That is very important. Okay. Right. So now, obviously, as far as my knowledge is concerned, women could have been given much importance to that one. So I will give 0 for female, 1 as male. 1 as male. Okay. So similarly, that suppose if you take which category is getting free ride in the buses, obviously female. So that there I will give 1 for female, 0 for male. So if you have 2 categories, and if you believe in that one category is having little lesser advantage, you give 0 for that category. The other category you can give 1. And this kind of variables which takes only 0 and 1 is known as dummy variables. We call it as dummy variables. And there are a lot of uses are there in this dummy variable analysis, which we can see little later. Okay, fine. And this is 2 variables category. Now there could be a possibility of, say, three categories also: white, black, others, 1, 2, 3. Or I can go with, education. Look at this one. Education. Oh, sorry. Yeah, occupational category. Let us take this occupational category. 1 is managerial, 2 is technical, 3 is service, 4 is farming, 5 is precision, production, and operation. So here, please listen carefully. If you want to go for a data analysis, theoretically speaking, as far as my experience is concerned, I used to classify into 3 groups. 1 is kind of a dummy variable, 0 and 1, provided if they have only 2 categories. Then you have more number of categories like middle, poor, middle, rich, you can be. North, south, east, west, you can. Primary school educated, high school educated, higher secondary school educated, collegiate educated, and professional education. What is the difference between north, east, west, south and this education? There, I just say north equal to 1, south is equal to 2, but doesn't mean that north is given the first preference. No, it's not like that. So that kind of variable, we are calling it as just a nominal variable. I simply nominate some number for north. It can be 1 or 2 or 3, 4, it doesn't matter. Like occupation. So here occupation is 1 is equal to managerial. That doesn't mean this is the preferable occupation. No. But in education, primary 1, high school 2, higher secondary 3, collegiate 4, professional 5. So there is an order. There is an order. I'm not giving primary 1, higher secondary 2, high school 3. I'm not writing like this. So some variables, even though if it is more than 2, you can arrange it in an orderly manner. So such a kind of variables are known as ordinal variable. Ordinal variable. If you just give a number like this, it is nominal variable. Okay. So maximum 99% of the variables can be classified into these 3 groups as far as my experience is concerned. 1 is 2 category, either or, so that I can say 0 and 1. That is also known as dummy variable. Then more than 2 categories, it can be without any order, nominal variable. With an order, ordinal variable. Any doubt here? Any doubt here? Okay, fine. So now I have entered the name of the variable. I have entered the label. This is very important because in your result, this is going to appear, not this one. So in your result, this is going to be appear. So you better write in detail. So for example, family income. I give a variable name, FLY_INC. Okay, right. Now, what does it mean? It is family income. So if I type here family income, is it enough? It's not enough. Then somebody will ask that if it is a family income, is it per year or per month? Then I have to say it is per month. Somebody will ask the number which you have typed, is it in thousands or is it the rupees? Then I have to say, so family income per month in thousands of rupees. So the label I give in this, could you able to see my screen? Suresh, could you able to see my screen?
Yes, sir. Yes, sir.
So could you able to see my cursor? I'm moving the cursor.
Yes,
could you able to see that? Okay, good.
Yes, sir.
Right. Okay, good. So listen here. So my point here is that the label is very important. So if you want, okay, see here you say that performance. So here you have to say, what do you mean by performance? Number of goals. Number of goals a particular person scored in a match. In a match. Or number of goals, number of times he helped to perform, to have a goal of a team. So you have to mention here very clearly without any ambiguity. Nobody should ask any question about that variable, but that doesn't mean that you have to write a paragraph. So pinpoint that it is very, and here the values. Values depends on how many categories you are going to take. Say for example, preference of the game. Preference of the game by the school students. So you will list out 10 games and there is no need for any order. Or you yourself may think that cricket is being chosen by everybody, so I will give cricket equal to 1. You are free. But in a nominal variable, whichever number you attach to your game, it is simply nominal. So there is no ordinal. You cannot say cricket is always better than football. Football is always better than badminton. Badminton is always better than kabaddi. It's not like that. You have 10 games, right? So 10 games, you attach 1, 2, 3, 4, 5, 6 times up to 10. And finally, you can add one more thing like others. Clear, right? So that is nominal. Ordinal, for example, sub-junior, junior, senior, veteran. So there is an order. There is an order in it. So you can say 1, 2, 3, 4, goes like this. Hope you understand, right? So now this is the variable view. So once if you define this, when you click this data view, there will be a blank space like Excel. So then the title of the variable which you have typed here will appear. You can enter the data. Suppose if you have 600 sports personalities data, then you will have 600 boxes to be filled along with 30 variables. So your data matrix, where did you start? You have started identifying the problem of performance of sports in rural area. What are the theories you have learned? Theories, you could say that no, performance is based on training. Performance is based on the physics of the food culture or time spent on the sports. Whatever you think, the theories will be definitely there. And then you identify the research issues, you have constructed a hypothesis, and then you have collected the data, you have identified the variables, and you have entered the variables here with variables, label, and values, and then you entered all the data. So now we have entered our data of our entire sample size. We have collected data, and what this one column speaks, one column gives different personalities data related to one variable. For example, here age, look at this one. Would you be able to see my cursor? Age. Age is a variable. How many person I have data? How many persons I have data? 1517. 1517 row I have. And how many columns I have? I have columns of 43. So what is my data matrix? 1517 rows and 43 column. So each row indicates 43 values. 43 questions have been answered by that first person. I have entered into that first thing. Yeah. So I have entered, the 43 values have been entered, and 43 values have been entered, and one row is related to one particular respondent, and one column is related to that entire samples value. Okay, so my data matrix is related to 1517 into 43. Is it clear? Right? Okay. So now up to this, is there any doubt? You can ask me. Is there any doubt for you to enter your data? Ma'am, Nisha. One second, please. I'm in class. Sorry for that. So any disturbance? I mean, any question you have now? Otherwise, I'll move to the next one. Is it clear? Any doubt? My dear participants, please speak. Unless you speak, unless you ask, you cannot get anything. First of all, are you all here?
Yes, sir.
Okay. Okay. Shall I move to the next one?
Okay, sir.
Okay, good. All right. Now, once if you enter the data, then what do you expect, or what you can do it? So based on your objectives, you can choose the statistical tools available to you. And most of the time we start with the frequency table. And then move to chi-square, and then t-test, ANOVA, two-way ANOVA, multi-level ANOVA, or regression, correlation, then qualitative data analysis like factor analysis, cluster analysis. So many things are there. Okay, fine. So now let us just start here. So I just go to analyze. I go to analyze, descriptive statistics. I'll straight away go to cross table, because I think most of you may be familiar with the power goes off. I do not know how much time I'll take this one. It's a problem. Louis, Suresh. Suresh?
Sir.
Power இப்ப போயிருக்கு, ஆனா திருப்பி வரதுல அப்படி இருந்தா
வந்துரும் சார், நீங்க பண்ணுங்க சார், வந்துரும்.
Okay, right, fine. Okay, right. So now I think I'll go to the chi-square analysis first, because most of the time we always try to connect the two qualitative variables, whether are they associated or not. Okay, fine. So now here I have taken two variables from this US General Survey. I have taken one variable called occupational category. Okay, I have chosen occupational category as my row variable. Okay, and then I take general happiness. The question here is for the 1517 participants, the researcher asked this question: what is your occupation? They have given the occupation. So based on that, 1, 2, 3, 4, 5, 6 have been given. And the next question is, are you happy? Are you happy after COVID? Or are you happy about living in a particular region? So that is the question. So here called general happiness. Is it okay? So you have two categorical variables. Say for example, again, you can take, for example, different games in the column wise. Here, gender or sub-junior, junior, something like that, or 5th standard, 5th to 8th standard, 9th to 10th standard, 11th and 12th, college. So this is a category of students. And choice of the game. You want to study the choice of the game. Is it related to the age of the respondent? Do you feel that is there any relationship or association between the age variation and the choice of the game? Any one of you? I said the null hypothesis, there is no association between age variation or age distribution and the choice of the game. Do you see like that? Okay, fine. So as an analyst, you collected data, and in this group of age variation, so you have put it that age group in the row, in this one, and in the column you have changed the choice of the game, or the other way, doesn't matter, right? Now you just have to reject or accept the null hypothesis. I repeat, my null hypothesis, there is no association between age distribution and choice of the game, right? Okay. And here I just taken some example, but whatever I do here, you can do it there, and you can reject or accept your null hypothesis. So just go to statistics. If I click statistics, you can see a lot of things here, but you just click chi-square. Chi-square is one of the familiar non-parametric tests. Parametric test is a test where that number is a matter. That number you can interpret. In a non-parametric test, the number is only helpful for you to test the hypothesis, but that number doesn't have any interpretational value. That is the simple difference between parametric and non-parametric. Is it okay? Clear, right? So I click that chi-square, I just continue, and the next thing is I go to cells. Each box, the cells. I just click row percentage, column percentage. If you wish, you can take a note of this. This is the basic analysis which you can add into any one of your article. Definitely it will add some better value of the basic understanding of the theory. If you keep on writing 5 pages, 6 pages, you can't impress the reviewer. But if you put some numbers, and numbers speaks a lot of things than the pages of writing. So here I just chosen row percentage and column percentage. I continue. Right? Okay. Now, just I click OK. I get a result. Could you see the result? Could you see the result?
No,
General
sir.
happiness?
No, sir. No, sir.
You're not able to see. Check it now.
Now we have see only the data view, sir.
Okay, I'll do one thing. I'll stop share, and then again I'll share that result so that you can. Yeah, now you can see. Am I right?
Yes, sir.
Good. Now look at this one. What is the row-wise occupation? Managerial, technical, service, farming. Now you can take it like this. This is the age between 10 to 15, 16 to 25. You can do it like this. Or you can take different states. Suppose if you take in the north one state, west one state, east one state, south one state, or district wise, you can put it like this. So whichever categorical variable, if you want, you can take it this side, doesn't matter. And here you will go to very happy, pretty happy, not too happy. Okay, like what is the answer? This out of 337 people, those who are working in the managerial, are you with me? Out of 337 people, those who are working in managerial, only 30 people, they have said not too happy. But the remaining people have said happy. The percentage is 8.9%. So only 9% of the managerial people are not happy about the life which they lead. And if you look at this way, 441 people have said very happy. Out of which this 441, this group, farming, you can see 2.3% of the people. 2.3% of the people have said, in the farming, they have said they are very happy. They are very happy. Okay. And so if you have six row category, 3 column category, there will be 6 into 3, 18 cells will be there. And in each cell, you will have a row percentage, column percentage. Row percentage means 38 plus 52 plus 800. 29 plus 31 plus 13 plus 2 plus 11 plus 11 is equal to 100. Clear? Right. So now you got not only one-way frequency table, it is a cross table. So I can combine these two things. Instead of taking only this or only this one. Fine? Right. That is also possible. So if you just go there and analyze, okay, and descriptive statistics, frequencies, okay, I'll just take general happiness and chart. I'll go with pie chart. I'll give continue. Okay, look at this one. Yeah. Could you able to see this table now? Could you able to see a pie diagram?
Yes, sir.
Look at this one. So it is a simple way of getting frequency. Frequency table always tells much about it. So this green is pretty very happy. So I can say in my total sample of 1,517 people, the 31% of the people have said very happy and pretty happy 58%. So if I put it together, it will be 89%. So 89% of the people are happy about their living life in a particular situation or a particular country. So missing is this many and not too happy are very less. So it is for a single variable. But if you go to this cross table, you can get this one. But I'm coming to that analysis of where did I start? I started with the null hypothesis of there is no association between the age group and choice of the game. Here, there is no relationship between occupation and opinion about the life. Opinion about the life. Is it okay? Right. Yeah. Right. Now, how do I reject or accept the null hypothesis? Rejection or acceptance of the null hypothesis depends on the confidence interval, level of significance, and so many things are there. Again, I don't want to go into statistics because if it is a physical class, I can teach you using board what is sampling distribution, what is standard error, why do we construct a confidence interval, and what is the region of acceptance, region of rejection. All those things I can teach you, suppose if I have a physical class. But now I'll just give you a simple formula of what it is, so you can use it. So here, the chi-square calculated value is this. You don't even remember that formula of summation of OI minus EI whole square divided by EI. The calculated value, table value. If the calculated value is greater than table value, we reject nothing. There's no need to worry about all those things. Simply take this sig value. Could you see there is a sig value here? It's a two-sided, two-tailed. Could you see the sig value 0.003?
Yes, sir.
Okay. So now the rule is take a note of that. Take a note of that. I think I can. I'll give you the. One second. Okay, fine. Okay, I'll call out. You can take a note of it. Take down. If the sig value is, take a note of it. If the sig value is less than 0.01, if the sig value is less than 0.01, we reject the null hypothesis at. We reject the null hypothesis at 1% level of significance. And we are 99% confidence about it. I repeat, if the sig value is less than 0.01, we reject the null hypothesis at 1% level of significance, and we are 99% confidence about that. Right. Number two, point number two. if the sig value is greater than or equal to 0.01, greater than or equal to 0.01, but less than 0.05, but less than 0.05, we reject the null hypothesis at 5% level of significance, 5% level of significance, and we are 95% confidence about it. 95% confidence about it. Point number 3. Point number 3. If the sig value is greater than or equal to 0.05, if the sig value is greater than or equal to 0.05, but less than 0.10, we reject the null hypothesis at 10% level of significance. 10% level of significance, which means we are 90% confidence about it. 90% confidence about it. Fourth point. If the sig value is greater than or equal to 0.10, if the sig value is greater than or equal to 0.10, we accept the null hypothesis. We accept the null hypothesis. Kindly read, and if you have any doubt, you ask me.
The last one, once again, you.
If the sig value is greater than or equal to 0.10, we accept the null hypothesis. This is the mantra of testing of hypothesis. If you remember this, it is enough for you to, whether correlation or regression, whatever it is, this is the 4 points you have to remember. And now here, what is the value of this sig value? 0.003. Am I right? So out of 4, which one will suit this? Two participants raised hand. You can just unmute your mic and ask me.
No, sir, good evening.
Huh?
No, sir, good evening.
Yeah, please.
But regarding the chi-square, now the 4 criteria to accepting or rejecting the null hypothesis. What
Yes.
about the other type of statistics? ANOVA, ANACOVA, MANOVA,
Everything, everywhere this is applicable. You stick on to null hypothesis and apply this 4 criteria.
Thank you.
And only for two-tailed test. I'm talking about two-tailed test.
Thank you, Professor. Thank you.
Just concentrate on null hypothesis, because if you reject it, alternative accepted. So you need not worry about it. Don't even give that in thesis. Null is this. I'm rejecting or accepting. That's all. For rejecting, accepting, these are the 4 rules. I boldly say that these are the 4 rules. Now, which rule can be applicable for this 0.03? 0.003? Could you see that cursor? Are we applying first rule, second rule, third rule, fourth rule? Speak. Be active. One of you answer. Which rule are we rejecting or accepting? What is the first rule says?
Second rule, sir.
Second rule, Amma? Eppdima? Less than 0.01 then Amma idu. 0.003. 0.003 is less than 0.01. So we are rejecting this at 1% level of significance, so that we are 99% confidence about this result. What do you mean by 99% confidence? If you repeatedly do this 100 times, this exercise, 99 times, you will come to this kind of conclusion. Maybe one time out of some issue. Otherwise, if you give this work for 100 respondents, 90 respondents, 90 researchers, 99 researchers will come and agree with this result. That's what the meaning of confidence. Okay, fine. All right. So this is the chi-square value and rejection or acceptance of this one. Right. Now, shall we go to another kind of an analysis? I'll stop this and then I'll go with the other kind of. And most of the time, what we do know, we'll try to compare, one group with, say, for example, let us take the average run scored by the debutant in cricket. What will be the average run in the first match? Any idea? Average run scored by a debutant in a cricket. How much it may be? Let us assume it is a T20. Somebody answer? Somebody answer. Be with me. Okay. Yeah. Okay, right. Now let me say that for a debutant, right? For a debutant in a T20 match, let us assume that he is a batsman, and I expect that they will score around 35 runs. I'm just telling you that 35 runs. Or whatever, I try to give you some examples related to your field, but I may not be so correct, but I just give you that one. So the expectation of a debutant in a T20 match as a batsman, he scored on an average 35. But this is my guess. And how do I accept or reject this hypothesis? My hypothesis, average score is equal to 35 by a debutant. How do I believe in or not? So what do? I have to take data from the scores by a debutants in the recent past. Okay, I just log into BCCI website and I found that there are 120 players have debuted, had the debutant, and in a different period of time, over a period of say 10 years, I don't mind about which period it is. I just take 120 debutants and how much they have scored in that first match. I have the variable. Could you guess? I have a variable. But what is my expectation? I said 35 is the average. Whether my theory is correct or not depends on the data which I have. The data which I have. Is it okay? So now here is an example, similar example. Here, this is data for around 100 and, sorry, how many people? Yeah, 474 respondents, those who have recently joined in IT sector. Those who have recently joined in IT sector, I got the data about what? Gender, birth date, education, job category, salary, beginning salary, job time, previous experience. Are they minority or not? I have the data. Now, I'll ask you one question. Please tell me, what is the beginning salary of a person who joined in an IT now? Please answer. What is the beginning first month salary of a respondent who has joined in an IT recent years? One of you please answer. Please be active. Unmute and answer. Beginning salary of an IT sector. Definitely, I think your brother or your sister would have joined. Somebody answer. Unmute.
Sir, 20,000, sir.
Hello,
Sir, 20,000. I think
okay,
the
good.
basic
Sorry,
salary for a
20,000.
fresher.
Okay, right. 20,000.
For a
Good,
fresh
right.
candidate, sir. Okay,
Okay,
sir.
fresh
Thank you.
candidate, 20,000. Right. Fresh,
Okay.
beginning salary, fresh. Sorry, somebody said 20,000. Let us check whether it is correct or not. I have a data. Listen here. This is the beginning salary data. Okay, this is the beginning salary, beginning data. This is given, right? Now, how do I test? You have entered your subject related variable like this, and you want to check. I told you, the debutante score is something different, right? Okay. Now, go to analyze. Please take a note of it. Go to analyze. Descriptive statistics are not descriptive. Compare means. Go to compare means. Compare means one sample t-test. Take a note of it. One sample t-test. I click, right? What is the data I have to beginning salary? Beginning salary is this one, test variable. In your case, it is the average score. Test value, how much it is? Here I have to type 20,000. In your case, you will type 35. Could you able to see what I'm typing?
Yes, sir.
Okay, good. So in your case, you will type 35 here. Here the girl said 20,000. I go to check whether 20,000 null hypothesis here is average salary is equal to 20,000. Either I will reject it or accept and appreciate that girl for correctly predicting that. Okay, fine. So now I have chosen the variable beginning salary and test value is given. Now I give OK. My result is here. Maybe you could not see that, so I'll click once again that result. Could you see the result here?
Yes, sir.
What is the mean salary here? 17,000. 17,000, right? But I have to accept or reject it. What is the Sig value here? 0.000. So please take a note of it. Whenever you get 0.000 as the test value or Sig value, you assume that as 0.0001. 0.001. Take it like that. So don't take that 0. If it is 0, then you can't say 100% confidence. No, 100% confidence is not there in statistics. So 0.001. So here I am rejecting that null hypothesis at 99% confidence with 1% level of significance. The girl who said 20,000 is not correct. What is correct? It is 17,000. Now I go back to the data. Okay, I'll go back to the data and check with I'll check my analysis goes compare means one sample test. Instead of 20,000, I'll put 17,000. I'll get result. Could you see the result now? No. Okay, I'll show you the result. Look at the result now. What is the Sig value? 0.965. 0.965, which is greater than 0.10, so that I'm accepting the null hypothesis. What is my null hypothesis? Average salary equal to 17,000. Now tell me, can you do a simple analysis like this about performance or average number of hours the college students now they are playing with, our average number of hours a tennis match goes? Anything. One variable, one claim, one null hypothesis, one variable. You can check with help of individual t-test. Possible? Can you apply? Okay, right. Now let us take two groups. For example, here, same thing. Average run scored by a player. And male, female. male, female. So there are two categories are there. Male players are there, female players are there. So average runs scored in a T20 match. And are they two different or same? Null hypothesis, there is no difference between male and female player in terms of the average number of runs scored in this 2022 or in the first match. It is up to you. There are two categories. There are two categories. Okay, you may even say that the average age of retirement from a game by male or female, is it different? Null hypothesis, there is no difference. But alternative is there is difference. So you have to collect data. One variable is whatever it is, average number of score, the age, retirement, whatever it is, one variable, and another variable is male, female. Male equal to 1, female equal to 0, or female equal to 1, male is equal to 0. It is up to you. Is it clear? So now two values. So now what I have here, yeah, I have two things. Now let me take the salary, beginning salary, and here I have gender. M is, look at this one. In the gender, I have female is equal to small f, male is equal to small m, instead of 0 and 1. But it is always better to go for 0 and 1. Clear? Right. Now I want to check the salary beginning. In the IT sector, there is no gender discrimination. So null hypothesis here, there is no difference between male and female in terms of salary, in terms of runs, in terms of retirement age, whatever it is. So there is no gender discrimination. Prize money by a tennis tournament, male and female, is there any difference? You prove. You just go and collect the data and just put it in one column for the variable, and then one column for gender. So now here, how do I analyze? I go to compare means. I choose independent sample test. One sample test is over, independent sample t-test. So here I put the beginning salary here, and the grouping variable is gender here. How did I group it? F, small m. You have to correctly place it. Small f, capital M, you should not do. Whatever you have given there in the data, you have to give it here. The variable name, value, you have to give it. So I continue here also. Okay, I get the result. I'll show you the result. I show you the result. Now look at that result. Female, 216 female, 13,000 is the average earning. Male, 20,000 is the average earning. Obviously, here itself, I could see there is a difference. There's a difference. But in statistical analysis, you have to always depend on Sig value. You should not go with just by numbers. Just by numbers. Why? The reason is, so for example, you want to buy a two-wheeler. You want to buy a two-wheeler. When you start from your home, you decide that, okay, if the two-wheeler costs 70,000 rupees, we will buy. Otherwise, let us not buy. You go there and discuss with them. You like that vehicle. So now they say final price is 75,000. Will you buy it or not? You will buy. So 70,000 and 75,000, the difference is 0. Though that 5,000 rupees difference is there, but that difference is equivalent to 0 for me. So in statistics, you have to go for the Sig value. So here, look at the Sig value. It is 0.000. So I'm applying that first rule. I'm rejecting the null hypothesis. So I'm 99% confidence that there is a difference between male and female in terms of average run scored. Do you understand? All right. Now, the next thing is, let us take, maybe another one. Okay. Could you see one SHG data? Self-help group data? Please answer me. Okay, I'll show you now. So look at this one. This is the self-help group data. or your sports camp data. Let us assume that this sports camp data. Now, in the sports camp, you have given a training for the, let us assume 30 students, irrespective of male or female, doesn't matter. You have given 1 month training. You have chosen, 100 cricket players from the schools, and you have given 1 month training in Chennai. Okay, you have taken 1 year before and 1 year after. 1 year before, what was the average score? 1 year after, what was the average score? For the 30 people, you have put it there. So now the null hypothesis is that there is no difference between before and after the training. The training is useless. So if you accept the null hypothesis, if you reject the null hypothesis, you will say the training gave given much needed skill for the young students so that their performance is well. After the training, their average score has gone up. The score has gone up. So training has an impact. So please have this training in all the districts. You can suggest as a research scholar. How do you categorically say there is an improvement or not improvement? For that, say assume that here I have the data for the, self-help group. Listen, I have collected data income before joining the self-help group, income after joining the self-help group, expenditure of the family before joining the group, expenditure of the after joining the group, savings before, savings after. So after joining the self-help group, after joining the training, what was the thing? So now you have to have, the data for before and after. Before and after. In the earlier case, income and male, female. The first case, only one variable. So this is the third type of t-test we are applying it. So now what I do analyze, compare means paired sample test. I think in sports, this paired sample t-test will be very, very, very useful to measure the kind of training you give prior and after had an impact, could be easily measured with the help of this paired sample t-test. I have chosen. So now what I do, I choose this two things, pre and post, family income. Where is it? Yeah, income of the respondent. I keep the shift. So I chose both and put it here. And I choose expenditure both. I put it here. I choose savings both. I put it here. So three variables I've taken: income, expenditure, savings. I'm an economics person, so I've chosen this sample. This is one of my MPhil students' thesis research data for them. So now I just go to options. I'll choose my I'll just give okay. I'll just give okay. Okay, now look at this one. Income before 7,700, after 8,500. There is a difference. Expenditure 3,500, after 4,500. There is a difference. Savings 1,400, 2,400, 2,100. Not that much difference.
So we could not able to see the results.
Okay, I'm sorry. Yeah, right. Now hope you can see this. Could you see the result?
Yes, sir.
Income before and after, expenditure before and after, savings before and after, it is there. Now look at the things. Look here, 0.001. So the prior and post income, there is a significant difference. We are rejecting. Expenditure, there is a difference. We are rejecting. Savings, we are accepting it. Beautiful result. So what has happened? After joining the self-help group, the family started earning highest income. So there is a significant difference between before joining and after joining in the self-help group. Expenditure also increasing. Before and after, significant difference at 1% level of significance, 99% confidence. But look at the savings. 0.113. The fourth category, accepting the hypothesis. Savings prior and post same. What does it mean? Any one of you can answer? What does it mean? Income increases, expenditure increases, savings remains same. What does it mean? So whatever income they earn, by going the self-help group, the women started learning better spending. Probably they would have got good education for their children. They would have sent their children to good private school or good government school where they could spend a lot of money, so that they earn better, they spend better, but keeping the savings as same, because they want to have a better living at the current moment. So this is a kind of analysis. We can do it in the sports also. And the one-way ANOVA, I can again go to the data. Yeah, this is the income data. Let us assume that you have income here. So these are income before and after. Let us take some category. Religion is there. Community is there. Let us take community. Community and income. Community and income. Let us take this two. And there are different communities are there. What kind of communities they have taken? Let us assume. For example, here they have taken 1 OC, 2 BC, 3 MBC, 4 SC, 5 ST. In real life situation, in a good a holistic economy, irrespective of the religion, everybody's income must be same. Am I right? That is what the best economy. But unfortunately, there is a difference. So if we have more number of categories, but one performance, like, okay. So for example, players from north, east, south, west. Players, and there is a general belief that players from west, especially from Mumbai, scored better. It was earlier theory, but now it is not like that. Okay, a person from Ranchi can score much better. But if there is a general theory, what is the average score from players from north, east, south, west? And the null hypothesis, everybody is scoring on the same average. Everybody is scoring on the same average. So here I have one variable called score, the next variable called region. 1 is north, 2 is south, 3 west, 4 east. 2 variables. I am applying one-way ANOVA. So if it has 2 categories, t-test. More than 2 categories, you have to go for one-way ANOVA. So I just go to analyze, compare means, one-way ANOVA. I choose that variable. So let us take the variable, for example, income here. I'll take income of the respondent after, I'll put it. Maybe expenditure after, I'll put it. Savings after, I put it. All 3 variables I'll take separately. And I'll go to option. I get that descriptive statistics I wanted because I want to know how much average income for each group. And then factor here is the community. The factor is community. I'll choose the community. Hope you've seen. Dependent variable, you can 1 or 2 or 3, whatever it is. I have chosen income, expenditure, savings. Category is community. Whether these 3 variables had a different for different groups or not, I have chosen. I've taken that income. I'll show you the result now. Okay, this is my results now. You could see the difference. Look at this one. OC, 7,000 income. BC, MBC is having highest income. And SC/ST, it is 6,000. Here itself, you can see there is a difference. But how do I accept it? But if you go to the Sig value, you see that there is a difference. There is a difference, but the difference is immaterial. The difference is not significantly different from 0. That's what they say that. So all the 3 things we say, irrespective of the community, the income, expenditure, and the savings are same because they have joined in a self-help group. Self-help group give loan for SC/ST and MBC, everybody is same. So though there are differences, the differences is not so statistically significant. so that we come to a conclusion that through one-way analysis, if every community join in self-help group, then there is treated as one community or one unity. So though there is a slight difference between income of family to family, but as a group, it is not like that. So that is why I told you that though the difference is here, but the difference is not significantly different from zero. It depends on the Sig value of what we had. So these are all the way in which you can get the result by using number, and you can write your thesis authentically. So if you include any of these things or all of these things in a paper, definitely the image of the paper writer and the paper, the strength of the paper will be better and better, and there is a chance of peer group review, and the chance of publication is very high in it. So I think you have to go for such a kind of data. And now maybe I think before concluding it, I'll just introduce what is the correlation and regression, right? Okay. So now I have the salary, current salary. I want to check whether the current salary and education has a relationship or not, or previous experience. Okay, I just go analyze, correlate, bivariate. I take my current salary and my education level and my experience. I put it together and I click OK. I'll get the result. I'll get the result for my correlation. Look at that one. I got the correlation coefficient. So current salary and previous year experience, there is a significant result, but it is a negative one. I don't know why, because sometimes even like in the IT sector, that is unfortunate that the senior person's salary is not gradually increasing, it is actually going down. And education level and current salary is positively related, significantly related. It is 0.66. And education level and previous experience also, negatively influencing. But anyway, so this is the way you can put it, the correlation coefficient into that one. And again, the rule of that 4 points which I have said is still remains same. And the null hypothesis here is there is no correlation between the variable which I have taken among others, among each other. And then I can even go to regression also. If I go to regression analysis, linear, I can take the current salary as my dependent variable and education as my independent variable, previous experience also my independent variable. I taken two variables, previous year experience and education. Maybe I can take age, it's not given here. Two variables. I take education level, which decides my salary, or previous year experience, this decides my salary. So I take the two as the independent variable and my current salary as my dependent variable. I just click and I get the result. You can see the result. Look at the thing. R square is 0.44, which means only 44% of the variation in my current salary is explained by the two variable which I have taken as an independent variable. But fortunately, the education level, it shows significant result, and previous experience also significantly influencing, and both of them are positively influencing. When I look at the correlation, it gives me wrong impression. But here in the regression, the cause and effect relationship, which is the cause? The previous year experience is the cause. My educational qualification is the cause. That decides my current salary. So what does it gives? Both of them are significant. I reject the null hypothesis that there is no association. I'm rejecting. So there is association. There is a dependency. So what does it mean? If my education level goes ahead by 1 year, every other thing same, my salary will be better than others in this group by 4,000 rupees. So if every additional year of education brings additional 4,000 rupees income, and then previous experience, every additional year of experience brings 12.71. I don't know if it is 100 or whatever it is, 100 or it may be current salary is given in terms of 1,000 means, then it will be 12,000 rupees. Okay, so it depends. So but both of them are significantly influencing. F statistics also significant. R square is significant. So this result is somewhat good for a cause and effect relationship study of regression and correlation. It's time I stop. So if you have any doubt, you can ask me, please. I'm willing to clear your doubts. I know that I'm just running. I'm not giving you everything. And there are a lot of things are there to study. Only by practice of yourself, you can learn this one, and you can gain confidence for interpretation. But I'll say that even if I am a reviewer of any paper, I will not encourage the papers without any statistical analysis, because most of the reviewers may be thinking that it is all like cut, copy, paste. Unless until if it has the data analysis with result, with proper interpretation, then only I think they will believe in that this is the original paper. So you can allow them to publish into that. So a good paper should have a good argument. A good argument is possible only with the good analysis, and the good analysis is possible only with the good data. Good data, you can collect it only when you know what are all the variables which are supposed to be collected. And if you want to know the good variables, you should have a good theoretical knowledge about that particular subject. It's all chain reaction. It is not one time attending or just listening that. Every day, at least half an hour to 1 hour, if you spend right from your initial stage of research, finally, when you come to your thesis, you will get self-satisfaction. This is a very key thing. You are not satisfying your guide. You are not satisfying your, you are not doing research to satisfy your guide or to satisfy anybody else. You have to be self-satisfied. Yes, I have collected data. I have analyzed. I have done this data analysis. I am writing this interpretation. This is my result. If you have that one, you can be more bold and confident. And even though if it is a wrong result, you can confidently defend that. This is my result. Yes, there is no relationship. This is my result. You can boldly say that. You can't always get the positive relationship. Even if it is a negative relationship, even if it is an insignificant relationship, boldly say that my data says that. That boldness will come only when you understand the concept, theory, and the data with the help of the statistical tools. Thank you. Questions, please, if you have.
Sir, in this session, we have understand how can insert the data as well as how can analysis for independent as well as parity test and one-way ANOVA, chi-square or correlation, we have understand. But before, as a researcher, after the data collection, what are the things we want to do? For example, whether to check the normality or when we are checking the parametric, or when we are going to parametric or non-parametric. So could you explain that one, sir? Because before entering the statistical analysis, we want to know about these all the things because of parametric as well as non-parametric. When we go for parametric, when we don't want to go for non-parametric.
See, the choice of tools should not come after data collection. The choice of tools which you want to apply, you must have in your mind before going for data collection. Right? So, when you do your review of literature,
so when we have to check the normality before test?
I'll come to that.
Okay.
So first of all, you must be very clear about your objective. And based on the objective, to study the objective, I want to apply certain tools. For example, you want to see the relationship between the performance and the training. Okay, right. The idea is to study the association between performance and training, or the age distribution and the choice of the game. So when it goes to age distribution and choice of the game, and if you want to look at the association, chi-square is enough. Chi-square is a non-parametric test. This you are not going to choose this chi-square after your data collection. No. Before even you going for a data collection, you must clearly know that my objective is to check the association between the age group difference and the choice of the game. So to do this objective, I have to apply chi-square. To apply chi-square, the non-parametric test, I need the variable of age distribution and the choice of the game. Right? Clear? So choice of the tools, whether it is correlation or regression, factor analysis, SEM model, whichever it is, before you go in for a data collection, you must decide that one. Most of our researchers collect the data and looking for somebody to know, sir, please tell me which tool I have to apply. That is a totally wrong approach, I can say. Because when you do your review of literature, definitely somebody would have applied chi-square. Somebody would have applied factor analysis. Somebody would have applied some other model. So you just collect those information and what you are going to do. What is your objective? Suppose, for example, you want to check the relationship between amount of training or number of hours of training and the distance time taken to cover 100 meters. Let us take like this, okay? Clear? Govindaswamy, are you listening?
Yes, sir. Yes, sir.
Right. So my point here, you are trying to see in the earlier case, age distribution and the choice of the game. There it is only non-parametric test. Right. Now you want to check the number of hours they train an athlete per day and the number of minutes or seconds taken to cover the distance. You have the data. You collected this data for say 500 students. Assume that. So one variable is 500 values of what? Number of hours they train every day. The next one is the distance, number of seconds taken to cover the 200 meters or 100 meters. These are the two variables you have. Here, how do I test these two things? I have to test only regression analysis. Regression analysis is a parametric test. So before even I collect the data, I decide that I want to see the relationship between these two, cause and effect relationship between these two. So I know that this is a parametric test. Okay, I'm going to apply regression analysis. For that, I'm going to collect the data of these two things. Once if you collected, you enter and click what I have done it. And then you can see if one more hour of training every day, the quantum of seconds taken has come down by half a second or 1 second. So that is parametric. Is it okay? Normality comes before your, before your sample size, you cannot apply normality. After collecting the data, you just apply that normality test, that Jakubara test, JB test, we used to call it as, and then you check whether the variable which you collected is normal or not. If it is normal, well and good. If it is not normal, you just see that where the bias is there. It will be a skewed distribution. So for example, you want to study about the quantum of money spent on sports, right? Quantum of money spent on sports by a family. Suppose if you collect all the 500 people from the affluent society in a city, will it be true data? Definitely not. So you have to collect something from rural, something from semi-urban, something from urban, something from metropolitan. So if your sample is a perfect sample, then the variation will be normal. Otherwise, it will be skewed one. Do you understand? So normality test will be applied to check the validity of your data variation. That is separate. That you can do it after your data collection. If you are not having a normal, then you can go back and recheck your sample size, or you can increase some more your sample units wherever there is a need. Fine, okay. And choosing a parameter or non-parameter depends on what you are going to do. So prior your data collection itself, you must say, this is my objective. For this, I am applying a SEM model. For SEM model, I need these variables. To get these variables, I will ask these questions to my respondent. Is it clear? Any doubt?
Yes, sir. Thank you, sir.
Anybody else? Anybody else?
Sir, good afternoon, sir.
Please.
Hello, sir. Sir.
Yeah, tell me. Go ahead.
Sir. Sir, இப்போ நீங்க correlationல ஒரு டேட்டா போட்டு காமிச்சீங்கல சார்.
ஆமா.
correlationல ஒரு டேட்டா போட்டு காமிச்சீங்கல சார்.
சொல்லுங்க.
அதுல வந்து மைனஸ்ல நமக்கு வேல்யூ வந்ததுல சார்.
ஆமா.
அந்த மாதிரி வேல்யூ வந்து ரிசர்ச்ல வருமா சார்?
வரலாமே. இப்ப நெகட்டிவ்ல
நம்ம எந்த மாதிரி எழுதணும் சார்?
ஏப்பா?
அப்படி மைனஸ்ல வந்துச்சுனா நம்ம ஹைபோதசிஸ் என்ன மாதிரி எழுதணும்னு கேக்குறேன் சார்.
இல்ல, அதாவது இங்க பாருங்க, இப்போ விலை கூட கூட பொருட்கள் வாங்குறது குறையுமா கூடுமா? விலை கூடுச்சுன்னா பொருட்கள் வாங்குறது குறையுமா கூடுமா? குறையத்தானே செய்யும். அது ரெண்டுக்குமா அந்த ரெண்டு வேரியபிளுக்கான தொடர்பு வந்து எதிர்மறை தொடர்பு. அதனால அந்த நெகட்டிவ் சைன் வருது. அந்த நெகட்டிவ் சைனை போட்டு தான் நீங்க எழுதணும், இல்லைன்னா அது தப்பு.
ஓகே சார், ஓகே சார், ஓகே சார்.
நெகட்டிவ் கண்டு பயப்படக்கூடாது எப்பவுமே. நெகட்டிவ் உள்ள எழுதி அத பாசிட்டிவா மாத்துங்க.
ஓகே சார், ஓகே. Thank you so much.
ரைட், நெக்ஸ்ட். வேற செந்தில், மோகன் ஏதாவது இருக்கா?
சார் நீங்க எதா இருந்தாலும் கேட்டுக்கோங்க சார்.
இது நல்லா இருக்கு.
வெரி சூப்பர் பிரசன்டேஷன் சார், சூப்பர்.
Thank you, thank you. ரொம்ப நாள் ஆச்சு இந்த மாதிரி கிளாஸ் எடுத்து.
கண்டிப்பா இந்த மாதிரி நானும் கத்துக்கிட்டேன் சார்.
அது வெரி ஹாப்பி, வெரி ஹாப்பி. ஐ திங்க் நெக்ஸ்ட் மேபி நம்ம பிள்ளைங்களுக்கு அட்வான்ஸ் லெவல்ல இதுல இருந்து எடுத்து போவோம். இதுக்கு அடுத்து ரிக்ரெஷன்ல இருந்து மல்டிபிள் ரிக்ரெஷன், அந்த மல்டிபிள் ரிக்ரெஷன்ல என்னென்ன ப்ராப்ளம்ஸ் இருக்கு, வாட் ஆர் த ப்ராப்ளம்ஸ் we face when we apply multiple regression, ஆர் அந்த டம்மி வேரியபிள் அனாலிசிஸ் எல்லாம் உங்க ஸ்போர்ட்ஸ்ல அப்படியே டைரக்டா அப்ளை பண்ணலாம்.
Okay, okay sir.
And I have come across one of my student have done a study on what is the probability of a match is being won by Indian team and Dravid score such a benchmark. புரியுதுங்களா? What is the probability of a team wins if a particular player scores a particular level? It has been done by review. இது வந்து லாஜிஸ்டிக் மாடல்ல பண்ணிருக்காங்க. லாஜிக் அனாலிசிஸ் ஒன்று இருக்கு, அதை யூஸ் பண்ணி இந்த மாதிரி அனாலிசிஸ் இப்ப நிறைய ஏகப்பட்ட அனாலிசிஸ் வந்து ஸ்போர்ட்ஸ்ல பண்ணிட்டு இருக்காங்க.
ஓகே ஓகே.
ஐ திங்க் நம்ம we have to train our யூஜி ஸ்டூடெண்ட்ஸ் கொஞ்சம் அது நோக்கி ஸ்போர்ட்ஸ் சயின்ஸ்ல ஸ்போர்ட்ஸ் டேட்டா அனாலிசிஸ், ஸ்டாட்டிஸ்டிக்கல் டேட்டா அனாலிசிஸ் அவங்க பண்ணாங்கன்னா இப்ப ஒவ்வொரு டீம், இப்ப சாதாரண கிராமத்துல இருக்கிற டீம்லயே அவங்க வந்து அந்த ஆப் வச்சுட்டு எந்த பிளேயர் எவ்வளவு ஸ்கோர் பண்ணிருக்காங்கறதெல்லாம் இப்ப என்டர் பண்றாங்க. உங்களுக்கு தெரியும் நினைக்கிறேன். நம்ம விளையாடுறப்ப அந்த ஸ்கோர் ஷீட் வாங்கிட்டு வந்து எழுதுவோம். இப்ப அதுக்கு ஆப் வந்துருச்சு.
நம்ம எங்க இருந்து வேணாலும் பாத்துக்கலாம்.
ஆமா, எங்க ஊர் பையன் வச்சிருக்கான். அவன் வந்து நான் இப்ப ஆவரேஜா இந்த மாசம் நான் இவ்வளவு அடிச்சேன், அடுத்த மாசம் இவ்வளவு அடிக்கிறேன். சோ அதெல்லாம் வரும்பொழுது இப்ப டேட்டா நிறைய இருக்கிறப்ப இது ஐ மீன் ஒரு டிஸ்ட்ரிக்ட் லெவல்ல எல்லாம் அனாலிசிஸ்க்கு நிறைய ஆட்கள் தேவைப்படும். So we can go for it. I think I am ready to support. Thank you.
Thank you sir. Rajkumar sir.
Thank you, Mohan.
Thank you, sir. Thank you so much for giving a wonderful explanation about all these things, sir. Thank you so much, sir. May I request our beloved Director of Sports to propose vote of thanks.
Good evening, one and all. On behalf of SRM Institute of Science and Technology, College of Science and Humanity, Department of Physical Education, Sports Sciences, and Department of Yoga, organized 2-day virtual national level webinar on how to write scientific research article and to publish in the Scopus and WOS indexed journals. We thank all the speakers, Dr. S. Aguila, Assistant Professor, Department of Physical Education, Bharatiya University, Coimbatore, and Dr. Babu Balraj, the Ambassador in the Carla for National Chang Asing University, Taiwan, and thank our beloved Dr. A. Duraiswamy, Dean CHS, SRM Institute of Science and Technology, and we thank our Vice Chancellor, Register, Additional Register, Madam, Deputy Register, Sir, Controller of Examination, and Deputy Dean, Anthony Raj, sir, and my own department head, Dr. Albert Chandrasekhar and Dr. M. Sendil Kumar. And thanks to organizing secretary, Dr. C. Suresh. And finally, we thank all the participants from various university. Thank you, one and all. Thank you.
Thank you.
Thank you, Director Sir. I thank all the participants for their patient sharing for the past 2 days. Thank you, Kundan. We shall meet in the webinar very soon. Thank you. Have a nice day. Pleasant.
So much.
Goodbye. Bye-bye.
Thank you.